This is about states of matter, solids, liquids, and gases. The basic kinetic theory model tells us about solids, liquids, and gases and its behavior. This theory tells us that matter is made of tiny particles, and these tiny particles are not at rest. These are moving particles. But the nature of motion in these particles is different in case of solids, liquids, and gases. But how and why the nature of motion is different in case of solids, liquids, and gases, this I want to show you with the help of model of solids, liquids, and gases. First of all, I want to show it from the model of solids. You see that the solids particles are so closely packed together. They are rubbing their shoulders with one another. They are so close. They are so much closely packed together. So the first point which must be in our mind for the description of these solids is that the particles of solids are closely packed together. This is the very important point. And this point will be a defining point of solids. When the particles are very closely packed together, it means they are holding power over each other. There is a holding power of them on each other. So the next point, of course this next point is depending upon the first point, and that is that the particles of solids are holding power over each other, and this is a reason that they tightly held each other. So the next point will be that they held each other very tightly together. So they are packed together, they have a greater holding power over each other, and they are holding each other very tightly. So after understanding this, I can bring the new points, and that is that you see that they are arranged themselves in regular rows. So there is a regularity in their position, and they arrange themselves in regular rows. So my next point is that the particles of solids are arranged in regular rows. Because they are so closely packed together, they cannot move freely. They cannot move from one point to another point. There is no free movement in case of solids. The only type of motion is the vibration. And this is a reason that my next point is that the particles of solids are vibrating about their fixed position. Just like I am at my disposition, and if I am still moving, this is the type of motion, but my position is still fixed. So is the motion made by the particles of solids, that they remain in their fixed position and they show the vibration type of the motion. So with all this understanding, we can say that these solid particles are closely packed together, so they must have fixed volume. So their volume must be fixed. And because they are closely packed together, they are holding a strong power over each other, so they cannot move freely. So obviously they have fixed shape. So their shape will be fixed. So they should have a fixed shape. So this is about solids. And you see that the one point logically leads us to the next point. So we should go step by step, gradually, in the understanding of the solids and the behavior of solids. My next will be about liquids. Of course, the behavior of liquids different as compared to the behavior of solid, and the model of liquid can show it. So this is about the model of liquid. You can see that there are some spaces between them. There are some empty spaces between them. So they are not as closely packed together as the particles of solids. So you see that there are some empty spaces between them. So you can see very clearly that they are not rubbing their shoulders with one another. They are not so much closely packed. Some of the particles are still attached with one another, and some of the particles have some gap in them. So the first point is that in case of liquid, the particles are not closely packed together. So when they are not closely packed together, of course, then there is less holding power, that there is less holding power of one particle with the other particle. So when there is less holding power, naturally my next point is that they are not regularly arranged, because they are not closely packed together, because there is less holding power. So of course this leads us to the next point, that they are not as regularly arranged as the particles of solids. So you see that they are all interrelated. So the one point can naturally lead us to the next point. And the next point is that because they were not so much closely packed, there was not so much greater holding power over one another, so they are not tightly held together. So they are not tightly held together. And next is, they can move about, they can slide past over one another, there can be a motion, they can move from one point to another point. So there can be a sliding past over one another. So there will be a slight motion. You can see they can move from one point to another point slowly and gradually. So the next is, of course, they can change their place. They can move from one point to another point. You see the water flows, and it tells us that water can move, and they have fixed volume. Why they have fixed volume? They have the fixed volume because they are still quite close together. When they are still quite close together and they can slide past over one another, so it means there are some holding power over one another. The particles of liquids have holding power over one another. So they remain close to one another, and this is a reason that they have fixed volume. And they do not have fixed shape. Why they don't have fixed shape? The reason is that they can show slight movement. With that slight movement, they can change their shape. They can change their shape according to the shape of the container. They can adapt themselves according to the container in which we place them. So this is about liquid, and with this understanding you can compare the properties of solids and the properties of liquid, and this model will help you in making contrast and comparison between the properties of solids and liquids. My next model is about gases, and in case of gases, you can see the model that the gases are, the particles of gases are away from one another, and they move. They can move. So the first point about gases that you can see very clearly that they spread out. So my first is that the particles of gases spread out. They go away from one another, and when they go away from one another, they are not nearby. So you see that they have less effect. The one particle has less effect on the other particle. So there is negligible holding power. There is a negligible, very, very, very small, so small that you can neglect it. Such a small holding power of one particle of the gas on the other particle of the gas, because they spread out, because they move away from one another. And they, of course, because of these 2 points, that the particles spread out and the particles have negligible holding power, so they are free to move. So gases have all sort of motion. They are totally free to move, and they can move from one place to another place very vigorously, very quickly. In a very short span of time, they can move from one point to another point. And because of these points, you see, if they have such a large energy to move, they have less holding power over one another. They are spreading out, so they are randomly arranged. Of course, there is all sort of randomness, disorder, chaos in case of gases. There is random. You can see they are randomly arranged, and they move very fast. They move very fast. They move very quickly from one place to another place, and they can move in all directions. They can move in all directions. Obviously, because of the previous reasons that they can move, and they can move in all directions. So you can see that they can move freely, they can change their position, they can move from one place to another place so quickly, so they do not have any fixed volume, and they do not have any fixed shape. So this is about that model of solids, liquids, and gas, and they can guide us about the behavior of solid, liquid, and gas, and they can tell us that why solids behave differently as compared to liquids and gases, and why each state of matter is unique and different because they are arranged differently, because the particles of solids and liquids and gases arranged differently, and that difference in their arrangement bring changes in them. There is some common mistake in the model of solids, liquids, and gases. For example, in case of liquids, it is a common mistake that liquid particles are well separated from one another. Actually, liquid particles, all the liquid particles are not well separated. You see that in case of liquid particles, some of the particles of the liquids are touching one another. They are still attached with one another. But sometimes students think that there is well separation in the particles of liquids. For example, if they make like this way, they show the complete separation in the particles of the liquid. This is wrong. This is a wrong model of liquid. The liquid particles and many of the liquid particles touch with one another. This is one thing we should take care of. Number two, in case of the particles of the liquids, there is a gravitational pull on them. So there should be a tendency that they should show the gravitational pull on them. For example, in this case, the gravitational pull is shown, but in this case, there is no sign of gravitational pull. So we should take care of these 2 points, that all the particles of liquids are not well separated from one another, and there should be a gravitational pull signs on the particles of liquid. And in case of gases, the gases must be arranged randomly. There must be a chaos in them, a disorder. So this is the right way. But if we show the particles of gases like this way, so they are so neatly arranged and orderly arranged, this is wrong. So we should take care of, because in exam this is asked to show the model of gases, liquids and solids according to the kinetic particle theory. So we must take care of these things.